Hi, welcome to another video of Chem with Com. We're finishing up chemical equations and chemical reactions. This is the fourth video of four videos. This one's called Oxidation-Reduction Reactions, or reduction, oxidation, right? All right. So oxidation-reduction reactions, or I'll just call them redox from now on, are a transfer of electrons. So something is losing electrons, another thing is gaining electrons, right? If you lose electrons, something has to pick it up, and it's all within that same reaction, right? So um, electrons are going to be transferred, and as soon as you know that electrons are transferred, you can classify it as a redox reaction. Okay, what's a redox reaction? Transfer electrons. What does that mean? Well, if your element starts with a certain what's called oxidation number on one in the reactants, and all of a sudden it's a different oxidation number in the products, that's a redox reaction. And we'll go through that on the next slide. So different types of redox reactions. Combustion, so a couple different kinds of combustion, but one that's very common has some carbon, hydrogen, and O2 in the reactants. And you see CO2 and H2O in the products. Again, very common, not all of them, but very common. So here, let's look. Hydrogen, O2, CO2, H2O, and this could be carbon or something else. Right? Here we have the carbon and hydrogen, O2, CO2, H2O. If you see a combination of something like that, that's going to be a combustion reaction, which is a redox reaction. All right, we also have single replacement reactions. It's usually the formation of ionic compounds. Um, so what's going to happen here is this A is going to kick B off. Not necessarily kick it off, but A replaces B, and now B is by itself, and you have A. Well, this happens here. Look. Cu, which is copper, replaces silver. Silver is now by itself, and copper is with nitrate. All right, combination, things coming together. Typically, not all the time, but I don't think it's all the time, but you have two things, you combine it into one thing, it is now a combination reaction. Now, things coming apart, AB separating to A and B. It's here, separating into hydrogen and oxygen. That's called a decomposition reaction. So four different types of redox reactions. All right, let's figure out how to do redox reactions and check out oxidation numbers. All right. So there's the book way. I'm not even going to explain it. You could try it out if you want. I make mine a little easier, and this isn't going to work for everything, but it's going to work for things in our class and most of the stuff you run into, right? So, okay, let's go down the list. All of the same elements in a molecule or compound will have the same oxidation number. So if I have something like H2O, right, that's two H's and an oxygen, these will have the same number. That's all that means. All right. Oxidation numbers within a compound, element, or ion must add up to its net electric charge. Let's explain that. Let's go up here, zigzag up here. All right. So if I said H2O, that means, and there's no charge here, right? There's no charge listed. I'll say no charge listed. So H plus H plus H, oh, sorry, H plus H plus O is going to be 0. And we'll assign oxidation numbers, but this is just the intro. Now check this out. Something like Al, let's do a different one. Let's do barium 2 plus. The charge of 2. There's only one element. right? So it's going to be barium has to equal +2, right? Let's do something a little funkier. This is called mercury 1, 2, 2 plus. Let's take a look. All right, these two mercuries have to add up to 2 plus. So I'm going to say mercury plus mercury equals +2. Now, what two numbers add up to +2? Well, +1 and +1. So the oxidation number of mercury is going to be +1. All right, let's do something now like sodium metal. Sodium metal, since there's no charge, sodium has to equal 0 because there's no charge. Again, the oxidation numbers have to add up to the net electric charge. Okay, now we start assigning specific things. Oxidation numbers are usually the same as their expected charges. You're going to assign them in order from highest to lowest priority. This is the highest on this side. This is the lowest on this side. We're going to go group 1. We know those are +1. Group 2, +2. Fluorine, -1. Oxygen, -2. Group 17, -1. Right? So we're going to assign those again in priority, and then we're going to check it out. I'm going to give you some examples. Remember, do all these in priority order, starting with number 1. So all of the same elements in a molecule compound will have the same oxidation, but all the hydrogens will be the same in order. 2 oxidation numbers within a compound element or ion must add up to the net electric charge. Let's work backwards here. Or we already did water, let's cancel that. Sulfate, it's 1 sulfur, 4 oxygens, and it's a 2 minus. So sulfur, oxygen, 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 oxygen have to add up to -2. All right, we'll come back to that one later. We're just thinking about the rules here. Copper, 1 oxide. There's no charge listed, so copper and the 2 copper atoms and the 1 oxygen atom have to add up to 0. And again, I'll go through some examples. Aluminum, there's no charge listed. There's only 1 atom, so the oxidation number has to be 0. Aluminum, there is a 3 plus charge. Aluminum 3 plus, because here there's no charge, right? There's nothing listed. So the oxidation number is 3 plus. There's 1 atom. That atom has to add up to 3 plus, so it has to be +3. H2, there's no charge listed, so there are 2 hydrogen atoms, so the oxidation number for 2 hydrogens have to add up to 0. So what 2 numbers add up to 0, right? Hydrogen and hydrogen have to add up to 0, so the only number that adds up to 0 is 0. Again, they have to be the same number. They can't be +1, -1. They have to be the exact same oxidation number. All right, so that means this is 0 for these hydrogens. All right. Usually, oxidation numbers are usually the same as their expected charges. Assign them in order from highest to lowest priority. Highest, lowest. Water is hydrogen, hydrogen, and oxygen. There's no charge, so it has to add up to 0. Assign the first group because it goes in the highest priority, group 1, that's H plus. So we know it's going to be, each of these hydrogens are going to have a 1 plus. Now you can figure out oxygen because those all have to add up to 0. So oxygen needs to be -2 for that to be true. So the oxidation numbers are hydrogen +1, oxygen -2. All right, next one. Sulfate with a 2 minus charge, right? The reason why we know it's 2 minus is because it's listed. So we have sulfur plus oxygen plus oxygen plus oxygen plus oxygen. We're going to assign the oxygen group first because, right, it's here. Sulfur's not even listed, right, as a group. So we're going to check it out. Sulfur plus oxygen, 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 oxygen has to be -2. We know oxygen is -2. So we assign -2 to all of those. So since those are -2, sulfur has to be a +6 for those to add up to -2. Oxidation numbers are here, +6 and -2. Again, the rules will change, and this is slightly, it just slightly, right? All right, let's roll. Let's keep moving. Let's check this. All right, assign oxidation states to the element whose atoms are underlined in each of the following compounds. So let's try it. Potassium, nitrogen, O3. So and there's no charge, so it's 0. So potassium plus nitrogen plus oxygen plus oxygen plus oxygen has to equal 0. Well, let's stop assign priority. First, we run into group 1, which is this one. So it's going to be +1. Nitrogen, we don't know. Oxygen now is -2. Let's add all this up. -2, -2, -2, +1. So we have this nitrogen still we don't know what to do with. That's what we're looking for anyway, right? But we have N plus 5 equal 0. We subtract 5 from both sides, N equals -5. So the oxidation for nitrogen is -5. All right, let's do NH4 1 plus. All right, so we have nitrogen plus hydrogen plus hydrogen plus hydrogen plus hydrogen equals a +1. In order, let's just go down the list here. Okay, group 1 is first, so this is +1, +1, and we have nitrogen here. That has to equal +1. So we have N plus 4 equals +1. -4 on both sides, N equals -3, right? Same element, nitrogen, different oxidation numbers depending on what it's bonded to, all right? So here N is equal to -3. Now let's check out this phosphate, or the phosphorus and the phosphate. So there's no charge, actually there's a charge here. It's a -1. So H2PO4 with the 1 minus equals hydrogen plus phosphorus plus oxygen 2, 3, 4 has to equal -1. All right, priority order. This is +1, +1. We don't know this. Then oxygen over here. -2, -2, -2, -2 equals -1. You add all that up, that becomes phosphorus -6 equals -1. Add 6 to both sides. These cancel out. Phosphorus equals 5. So phosphorus equals, I'm just going to put a +5 so that we can see visually it's not a minus. All right, that's going to take practice. I suggest starting over on the last one and doing it with just your notes without listening to me. That way you can get practice at this. All right, now let's do it in context of a chemical equation. So let's assign oxidation numbers to every single one of these. Sn, there's no charge, so Sn has to equal 0. So the oxidation number is 0. All right, so I'm going to put a 0 here just to show you that it's 0. Let's do HCl. HCl, no charge. So H plus Cl equals 0. Let's do priority order. Well, group 1 is +1. You go down the list, you see group 17, it's going to be -1, that equals 0. So hydrogen has a +1, chlorine has a -1. All right, I'll put it over here. Hydrogen equals +1, chlorine equals -1. Right. 10 to chloride. Again, there's no charge, so it's going to add up to 0. So 10 plus chlorine equal 0. Go down the list. Group 17. So this is -1. And this is just 10. So it's going to be 10 plus 2. Oh, sorry. 10 minus 2 equals 0. Plus 2 on both sides. 10 equals 2. All right, so this is going to be, and then chlorine equals -1. Plus 2, -1. All right, let's take a look here. H2, there's no charge, so that adds up to 0. So H plus H equals 0. The only thing that adds up to 0 is 0, right? We can't do group 1 because if it was +1 that would equal 2, and we can't do that. So H equals 0. Let's write that up there. Okay, now did oxidation numbers change? For the same atom? Well, let's take a look. We have 10 as 0, 10 as +2. So we say 10 went from 0 to +2. Yes, we change. Yes, it's a redox, right? You can also see that here with the hydrogen. Hydrogen went from a +1 to a 0. So yes, this is a redox. And if we had to define what type of redox it is, we'll say yes, redox reaction. And if we go back up here to our little list, right, it's a single replacement reaction. That's the type of reaction it is. All right, so go back and practice that. Here's a summary of the reactions, which is last video and this video. So we have precipitation reactions. Typically, two solutions are mixed together to create a solid. We start out with two aqueous solutions, and we get a solid at the end. That's a precipitation reaction. Acid-base reactions. combining an acid and a base to make water and a salt. So we need an acid that provides the hydrogen, a base, usually it's hydroxide or carbonate, and that makes water and a salt. Oxidation reduction reactions, redox. There's a transfer of electrons. Combustion usually has some hydrogen, some carbon, and O2. And their reactants have CO2 and H2O. And this is usually, right? Most of the combustion reactions are like this. Single replacement, A replaces B, B hangs out by itself. So you have here B by itself. Combination, A and B coming together to make one single molecule. And then here, a molecule coming apart to make two different molecules, which is a decomposition reaction. So save this summary slide. It'll help you through whatever you're going through for chemistry, for reactions wise. All right, I think that's it. Thank you very much, and I will catch you next time. Have a good day.